Welcome to the session, and in this session we're going to discuss some clipping mechanisms and the clipping algorithm with respect to OpenGL programs. So now when I'm going to talk about a clipping algorithm or a clipping, so now when we are discussing about the viewing or a viewing window or a viewport, so we discussed about how the clipping is going to happen. That is, the object which you want to visualize right now will be displayed in the viewport, and whichever the object will be outside the viewing window, we will say that we are going to clip out those objects from the scene. That is, we are going to eliminate those portions. That is what, when I say clipping or a clipping algorithm, or the procedure what we are going to follow for clipping operation, that is what the procedure we call whenever we are going to eliminate a portion of a picture. So now when do we going to use this clipping process, or when do we require the procedure for clipping? So I've just put you some examples where exactly the clipping is going to come into picture. Now for example, when I'm going to talk about the solid modeling methods, in this scenario I do need clipping. You can just observe, I've just put an example here. This is not exactly what we do in OpenGL program, but it's the application of clipping where all we can bring in. That is, now just for example, look at this. We have combined these three objects and we have formed. Now it is not any clipping operation. And now if I just observe these two operations, when I combine these two operations, now whichever the object is going to be placed, when I place the sphere in this, you can see some part of the cube has been clipped off, and even the some part of the sphere has been clipped off. Even the same thing happens here when I'm going to combine these two. Whatever this portion is going to be in the scene, I'm going to clip off. And this is one application of clipping which is going to be in the solid modeling methods. And other applications, whenever we are going to have a single object, for example I'm going to have a single object, and if I want to visualize part of this object in different window, I can do this using clipping operation. That is, I will take the first part, clip out the second part, display in the first window. Take the second part, clip out the first part, display in another window. Hence, whenever I want the multi-window management or in the multi-window environment, I should think about the clipping operation. And if I'm going to talk about anti-alias object boundaries. Now for example, just look at this object, and if I zoom in, you can see the edge is not smooth. So when I zoom in this portion, the edge is not smooth. So now I'm going to apply the clipping operation. I'm going to clip out some pixels on these edges, so that after a clipping operation, I'm going to get the edges to be the smooth edges. Hence, so the edges what I had earlier, it was not smooth enough, but using the clipping operation, by clipping out some pixels at the edges of the object, I am able to get a smooth surface, or smooth enough surface. So the few examples where I can bring in the clipping procedure, clipping operation. And even whenever I want to move part of an object, if I want to move the complete object, I am not going to think about a clipping operation. But if I want to move part of an object, or if I want to copy the part of an object, or if the part of the object should be deleted, at that point of time again I can think about the clipping operation, so which we can bring into the OpenGL program environment. And so when I'm going to talk about clipping operation, these are the few of application what I can bring in. And the efficient implementation of a clipping algorithm is applying this with the normalized boundaries, so which we are going to use that as a default clipping window. Whenever we are going to talk about clipping operation, just think about it's a process of normalizing your object coordinate system in whatever the coordinate system I'm going to work with or design with, or I'm going to use with the graphic pipeline. So some or the other point, we need to bring in this coordinate system to a normalized coordinate system. Hence we call this as normalization. If I do so, we call this as efficient way of implementing an picture definition with the clipping operation. Hence, so this is what exactly happens in the graphics pipeline. Even you can bypass this normalization and the normalized coordinate system, and you can directly put into the device coordinate system, but it is not the efficient one. If you want a efficient OpenGL program or any graphic system, so we need to bring in the concept of normalization, which is the default clipping window for us. Hence, the discussion what I make, usually we are going to take the normalized coordinate system, and by default the normalized coordinate system values is going to be -1 as the left value, +1 as the right value, and the bottom value is -1 and the top value is +1. If you remember what values I am talking about right now, it is with respect to GLU ortho 2D function, which I had discussed in the previous session. Fine. And now with this, so we call this as -x, we call this as +x, this is the -y axis, this is the +y axis, and this edge usually we call this as x minimum, and we call this as x maximum, and this is y minimum and y maximum. This is the default what happens in OpenGL program. And when I'm talking about clipping algorithm in the normalized coordinate system, we are going to now discuss about the clipping a point. So how we're going to have a point clipping and clipping a line in the line clipping algorithm, and clipping a polygon or the interior of a polygon using polygon clipping. Fine. So now we will see how exactly these three is going to work in clipping algorithm. When I talk about a pointing clipping, so we are going to have the clipping window, the default normalized coordinate system, and I have just told you what is XW minimum, the clipping window minimum X value, the clipping window minimum Y value. Similarly, this is supposed to be max. So please make a correction here. This is supposed to be max, X max and Y max. And this is the clipping window what I am going to have. And you know what this -1 is going to be X minimum, -1 is going to be Y minimum, and +1 is X maximum, and +1 is Y maximum of your clipping window. Now having this setup of clipping window, now just look at this, how we are going to clip a point. So to clip a point, it's a simple basic rule. If a given point is going to be inside the clipping area, if it is inside the viewing window, then the point should not be clipped. It should be saved for the display purpose. If the point is going to be outside this area, then that point should be clipped off. And this is a basic or a simple rule. Hence, to have that, you should know what is XW minimum and you should know what is XW maximum, and this entire edge is XW maximum, this entire edge is XW minimum, this is YW minimum, and this is YW maximum in your coordinate system. I hope you have understood what all these edges is going to be and the default value for the edges. Fine. So now I'm going to decide whether this point is inside or not. So to do so, it is a simple conditional operation or the comparison operation. It is just the relativeness of the values what I use with this 4 statements, the 4 relative statements. If all these relative statements are true, if all the 4 statements are true, then we can clearly say the point is inside this clipping area. If any one condition will fail, if any one condition is false, then surely the point is going to be outside the clipping area. It's a simple rule. Hence, if a point wants to be inside the clipping area and should be saved for the display purpose, then all these 4 conditions should stand true. If any one condition fails, it need not all the condition to be fail. If any one condition out of this 4 fails, then the point should not be saved for the display. It should be clipped off. Fine. This is the simple basic rule what you're going to use whenever you talk about 2-dimensional point clipping. Fine. So now with this, just look at this example now. Let me take a point P1 which is going to be at minus 0.7, 0.6 in your coordinate system, because if this is minus 1 and if this is plus, so 0 is exactly at the center, and so now this we can call this as approximately minus 0.7 because this is in the minus x-axis. So similarly, if this is plus 1 y-axis, minus 1 y-axis, so approximately I guess this is going to be 0.6, hence the point P1 is at this x and y value. And so now we will check whether, so as I view, so clearly I can say as the point is inside the clipping area. But how does the algorithm knows and how does the algorithm will process it now? And so the first condition is I need to check whether the x value, which is minus 0.7, is greater than minus 1. Minus 1 because xw minimum is minus 1. Is the condition true? Yes. Minus 0.7 is going to be greater than or equal to minus 1. It is true. This value is greater than minus 1. Hence, so nothing problem in this. It's true. And the next value, the same x value minus 0.7, is it less than or equal to 1? Because the x maximum is plus 1. Hence, even this is true. And we'll take the y value now. 0.6 is greater than minus 1. Yes, it is true. And 0.6 is less than equal to 1. Yes, it is true. Hence, all the 4 conditions are true. Hence, the point P1 should be saved and should be saved for the display purpose without clipping it out. Fine. So just look at one more example now, where I'm going to take P2 point. So intentionally I have made this to be outside the clipping area. Hence, right now any one of this condition should fail. Hence, this point should be clipped off. Now we are going to have P2 equals minus 1.5. Approximately it's going to be at minus 1.5 in the x-axis, because if this is minus 1, I am moving behind this value, and this should be 0.5 more, hence minus 1.5, and the y value, it is going to be in the minus y-axis, hence minus 0.2 approximately. Fine. So now we'll just check the first condition. The x value is minus 1.5. Is it greater than minus 1? Is it greater? Now this is going to be false. It is false because minus 1.5 is not greater than minus 1, and this will fail. And what about the next condition? It is true. Minus 1.5 is less than 1, and the y value, that is minus 0.2, is greater than minus 1. Is it true? Yes, it is true. And I'm going to have the next value, minus 0.2 is less than equal to 1. Yes, it is true. Now, out of these 4 conditions, one condition failed. Hence, as soon as I got the first condition to be failed, I would have not checked any other remaining condition. Directly, I would have been clipped off. Just for explanation purpose, I have just showed you the complete procedure. Now, the P2 point should be clipped off because one condition is false, whereas P1 will be not clipped off because all the 4 conditions are true. Now this is how the point clipping is going to work. Hence now this point is clipped off and this will be saved for the display purpose. Fine. Hence now this is how the 2-dimensional point clipping is going to work. And in general, we will say when the point clipping algorithm will be implemented, whatever the points x value I am going to take, make sure it is in the range of w minimum, x minimum, wx maximum if it is in this range, as well as y is also in this range if both x and y are in its respective ranges. Only then we are going to save the point for the display without clipping it out. If any one value or both, if it is out of range, then we are going to say this point is out of clipping area and should be clipped off. This is how the point clipping is going to work. So now we will just see how the line clipping work is going to work now. Now just look at this example and the lines what I have put over here. I have put line 1 here, which is formed using P1 and P2, and the second line which I'm going to have P5 and P6, and I'm going to have one more line which is made up of P3 and P4, and the two more lines. If you just observe, there are different set of lines over here. Just carefully observe what are the different types or the different lines what I put here. Each is going to depict a property here. Just look at this. The first line, this line is completely inside the clipping area. Fine, just observe this. And if I just observe the second line made up of P3 and P4, it is completely outside. Fine, it is completely inside and it is completely outside. And even if you look at this line, this is also completely outside. But observe one more difference between these two. So though both the lines are completely outside, this line is outside at any one edge. At this edge, the x minimum edge or the left edge, if I keep the reference of the left edge, by keeping this reference, I am saying this complete edge is outside the clipping area at one side itself or the one edge. So though this is outside, completely outside clipping area, but it is outside the two edges. It is outside with respect to y max, with respect to y, and even with respect to x. It is outside at the two edges. Fine. Hence, when we say a line is completely inside, there is no any confusion with this. There is no any more category I can make it out. But when I say a line is going to be completely outside, it can be outside with respect to only one edge, or it can be completely outside with respect to two edges. Fine. Just observe this. And now just look at this line. I am going to have a line, so which is going to be partially inside and partially outside. Even I am going to have one more line which is partially inside and partially outside. But the difference between these two lines, though it is partial, is this line is going to intersect the edge only once. It intersects any one edge. Whereas this line is going to intersect two edges. This is what the different set of lines what I have depicted here for your understanding purpose. And so when we are building a line clipping algorithm, we need to take care of all these cases, all these issues. Fine. So now we will see how this is done, how the clipping is going to work on when I am going to work with this many scenarios. And the algorithm or procedure what I discussed now will make sure it's going to clip all these lines. Fine. So now we are just going to have the clipping algorithm, and whatever the procedure we are going to bring now, whatever the procedure we are going to use now. So you need to make sure that whatever the parts is going to be in the clipping area should be saved. When I say a line is partial, so you are not supposed to reject the entire line. You are not supposed to reject. You need to reject only the part of the line which is outside the clipping area, and the remaining part which is inside the clipping area should be saved. Hence, when I clip out the part of the line, even I am clipping out this point also. Hence, this point should have a new point values. It should have new x values and it should have new y values. Hence, if I'm clipping out P5, I need to make sure I have founded P5 dash. Similarly, I'll be clipping out P7, and you need to find the new values for the P7 as P7 dash. Similarly with the P8. Hence, when I say clipping a line, I am not going to clip the entire line if it is partially in and out. Fine. So we need to save the part of the line and we need to clip out part of the line. So the similar way what I have been depicted over here. Something after clipping operation, this should be my output. Fine. So I hope you understood what your line clipping algorithm is supposed to do. Hence now we will see how exactly this is done. Fine. So now we need to determine the line algorithm what we use now should be able to determine whether the entire line or any part is to be saved. That is, should I save the entire line or should I save part of the line to be saved? And the procedure to calculate the intersection position is the complex part over here. It is the part which takes much of the time. Hence, if any line is intersecting as partial line, I need to find this intersection point. We call this as intersection point. Hence, P5 was a point of a line. Now P-5 becomes the intersection point. Fine. Hence, I should be able to find the intersection position of the point which I am going to clip out. And the major goal for any line clipping algorithm is to minimize the intersection calculations. So which we'll see later how exactly we can do this. But it should be the major goal because the intersection, finding the intersection point is a complex part of any line clipping procedure or algorithm. And so now, when I talk about any line clipping algorithm, these are the few of the points which we need to work on. The first point is I need to find whether line is completely inside or completely outside. The first step is I need to make sure whether it's completely inside or completely outside. If it is completely inside, save it for display. If it is completely outside, just clip it out or delete it from the display. If it is not completely inside or outside, that is where we call it as the partial line, which should be saved as well as deleted. Then we need to determine the intersection point. We should get an intersection point. So now I need to clip out the line from P5 to P5 dash, and I need to save the line from P5 dash to P6. This is what your line clipping algorithm is supposed to do. Now we will see how exactly this is going to work. So now whenever going to get a line, we are going to test a line if it is completely inside or outside using point clipping method. The first way is we are going to test a line. We're going to test every line by taking the points of a line, because we know that every line is made up of 2 points. Now we are going to use the point clipping method. Previously I have discussed how the point clipping is done using the 4 conditions where the x should be in the range and y also should be in the range. We'll use the same method. We'll use those method for the 2 points. If both the points are in the clipping area, then we'll say the complete line is going to be accepted. It is completely inside. If both the points are outside the clipping area, then we are going to say it is going to be completely outside. And if one point is inside and one point is outside, now this is where we say the line is partial and we need to find the new intersection point. Fine. Now we will see how exactly we are going to make use of this. Hence, by using the point clipping method of the range of x and y, we'll see how this can be done. Fine. So now to do this using a point, so both the endpoints of the line are inside all the boundaries. I should check for all the 4 boundaries of the clipping window. Both endpoints of line are outside from any one of the 4 boundaries. Fine. That is, when I talk about both the endpoints, if they are outside, it is to be at any one of the 4 boundaries. That is the type what I discussed. Even this line is completely outside, and if this line is also completely outside, but this line is completely outside at the one side of the boundary, that is the left boundary of the clipping window, but this is outside at the 2 boundaries. Fine. And for this purpose, when I discuss about the point clipping method, this point clipping method is going to address only this problem. Now when you come at this point, though it is completely outside, it is not considered to be completely outside. It is considered to be partially outside. It is partially outside for me. Hence I am not going to reject the line. We'll consider this as partial, and we are going to find the intersection. Clear? Hence, if both the test fails, the line may or may not intersect the interior. This is what I told. If it is not completely outside and if it is not completely inside, then the line should be partial. Even this line is considered to be partial. This is partial and this is partial. Hence, we say if both the test fails, the line may or may not intersect the interior. Now this is not intersecting, this is partial, this intersecting, this is partial, it is also intersecting, this is also partial, which is not intersecting. So clearly understand how we are going to use a point clipping method to clip a line. So now we will use this method in our program with an example. So now when I bring in the line clipping algorithm, we are going to use the parametric form. The line clipping algorithm, what I discussed now, is going to use the parametric representation as parametric form. Now just note down this equation. Now this is the equation which will help me out to find whether the line should be clipped or not clipped, or is it partially clipped or partially saved. So now hence we are going to find the x value and the y value if I want to find the intersection. Hence now whatever this u value I am going to use in this form, now this is going to be the parametric value. Depending upon this parametric value, we are going to say whether the point should be clipped or not, whether the point is intersecting the edge or not. If the value of u is between 0 and 1, if the value of u is between 0 and 1, then we say the point is intersecting the edge. If the value of u is not within the range of 0 to 1, then we say the line is not intersecting. You need not worry about any intersection point calculation. Hence, we are going to use this parametric form to clip out the line. You clearly understand how this is going to work and what is the u value is going to be and whether it's going to be in the range or not by just looking at the example what I discussed now. Now just look at this. So we will clearly understand how the parametric form will be used to clip out a line. So for that, just look at this example. I have taken a clipping window, and when I say clipping window, it should have x minimum, it should have y minimum, which is going to be this bottom left corner. And I am going to have x maximum, I am going to have y maximum, which is going to be top right corner. I am just going to have these two endpoints. And you know what this x minimum on the x axis is going to be and x maximum on the x axis is going to be. Now we call this as left edge, we call this as right edge, this is the bottom edge and this is a top edge. And these are the 4 boundaries what I am going to have for any clipping window. Clear? So now in this example, x minimum is going to be 100 and x maximum is going to be 200, y minimum is going to be 50 and y maximum is going to be 150. This is what have been considered. This is what the clipping window have been set. You can set the value of clipping window of your choice, anything what you want, but this is what have been set. So now I am going to take line 1, which is made up of P1 and P2, and the P1 value is going to be 120, 70. Fine. On the x-axis, P1 is going to be 120 and y is going to be 70. Similarly, P2 is going to be 140, 100. That is x1, y1 of P1, x2, y2 of P2. Similarly, I am going to have one more line which has got P3 and P4. P3 has got the values 160, 135, and P4 has got the value 220 and 52. This is the two lines what I am considering, and the first line will not be clipped. So it is entirely inside, hence you are not supposed to clip anything. Whereas this point is going to be partially inside and outside, and we'll see how this clipping is done. So I am going to show you how you're going to work with these two lines. So similarly, you can apply for any type of lines later on. Fine. But in this video, I am going to discuss only upon these two types of lines. Fine. And so we will see the first line first, how we are going to check whether this line is completely inside or not. And whenever you're going to work with the line clipping, I need to work with all the four boundaries of the clipping window. One by one, I should work on all the four boundaries. That is what I call this as step 1. At the step 1, I am going to be at the left boundary, which is x minimum as the boundary edge. That is the left boundary edge. Being at this edge, I am going to check whether the line is going to intersect this line or not. Is it fine? So whether the given line is going to intersect the left edge or not. Hence, so we are going to check whether this is going to be using the parametric form. The parametric form is going to be this equation, and now I am going to replace x with x minimum and find u. So because I am working with the left edge, and the left edge is something to do with the x-axis, and right now just concentrate on this form only to find the value of u based upon this form. If it intersects, then we'll look at this form. And so now I am at the left edge, x minimum is at the first step. So replace x with x minimum of this form and find the value of u. Hence, so x is replaced with x minimum, and right now I am talking about P1 and P2. So P1 is made up of x1 and y1. So right now this is a line, hence I replace xi with x1 plus u, and xj is x2, that is the x value of the 0.2 minus the x value of 0.1. That is what this form is going to do. And the y values, y equals y1 plus u, y2 minus y1. So now we will just find what is the u value by solving this equation. Hence, if I replace all these values, I know what is x minimum. X minimum is 100. So replace that value. And I know what is the value of x1. x1 is 120 plus u into x2 is 140. So 140 minus x1 is 120. So if I solve this equation, so just try to solve this, try to find the u value in this case. When I try to solve this, I am going to get the value as -1. I am going to get the value as -1. And I have been named, rather than just putting this as u for explanation purpose, I have put this as UL. L stands for left. That is the left boundary of your clipping window. I am using L because I am finding what is UL right now. That is the U value for the left. Now this U value will tell you whether the intersection of line has happened or not. If the U value was within this range, then I would have told the line was intersecting. But right now look at this, u1 value is -1, so -1 is not in this range. Hence, there is no intersection of the line with respect to left edge. Is it clear? So now, if this is done, so don't stop your algorithm at this point. I should do the same operation for the remaining 3 boundaries or the edges of your clipping window. Hence, now we'll move on for the step 2. In the step 2, we'll consider the right boundary. Hence, in the right boundary, it is x maximum. Hence, I replace x with x maximum now. At the step 1, I replaced with x minimum. Now I am replacing with x maximum, and the equation remains same now. Only I am replacing with x maximum. And so now I am going to replace x maximum 200 and find the value of u. And the u, I have replaced this with r because this is for the right boundary. Hence ur equals 2. And whether this 2 is within this range? No, it's not within this range. Hence, the line will not even intersect the right edge also. And right now you might be assuming I am just replacing the values for the x parametric form. I have nothing to do with the y parametric form. I need not do anything because I am going to consider the y parametric form only when there is an intersection with the edge. That is, I am going to consider this parametric form to find the value of y only when the value of u is going to be within this range. Fine. So right now don't have any confusion in this case. So now we will just move for the step 3, where I am going to consider the bottom boundary or the y minimum. And so replace y minimum with the y value now. Now consider this parametric form. So keep the x parametric form as it is with the x value and y values. So now it has been flipped now. I will be replacing y with y minimum and try to find the value of u. And this form will be used only when the value of u, what I find now, is going to be in this range. And so now replace this y minimum with the value as 50 because y minimum is 50. So 50 equals y1 value is 70 plus u into y2 value is 100 minus y1 value is 70. If I solve this equation for u, I am going to get u as minus 0.67. It's ub because for the u for the bottom edge. Hence, so minus 0.67 is again not in the range. It's not still in the range of 0 and 1. It is beyond 0 value. Hence, so even there's no intersection. Now at the step 4, I will take the top boundary where I replace the value of y maximum with the value of y. Hence, I am going to replace this as y max, that is 150, and solve this equation where I find ut, which is going to be 2.67, which is again not in the range. Now if you just observe in all the 4 steps with respect to all the 4 edges, so none of the u value is going to be within this range. Hence, there is no any intersection of the line with any boundary. Hence, right now we say the complete line is going to be within the range. It's going to be within the clipping window, as entire line is completely saved or accepted. This is how it's going to work. Now we'll just look at the next example, the next line, so which is going to be P3 and P4. And you know what is x3 value, y3 value, x4, y4 value. Again, we'll go with the step 1, step 2, step 3, step 4, same, so on. So now in the step 1, replace x with x minimum and find the value of u. And now the x minimum value is going to be 100 and the x3 value is 160 plus u, and x4 minus x3 value as 160. Now this you are going to clearly understand. Now find the value of u. u is minus 1. Again, it is out of this range, and there is no intersection, and I need not find the value of y in this case. And now in the step 2, I replace x maximum with the x value and try to find this equation now. With the x maximum being 200, if I solve this, now just look at the value of u. Yes, the value of u is 0.67, and this is within the range. That is 0.67 is greater than 0 and less than 1. Yes, it is within the range. When this is within the range, then there is an intersection of the edge with the boundary, and it is true so with our example. So now it is having a intersection. Now I need to find the value of y. Now just observe, when there is a intersection, I need to find a new point for this P4 as P4 dash. I need to find P4 dash. Now just give a thought here. Now what is the x value of this new point is going to be? It is same as x maximum. It is going to be in the same x-axis. Hence I need not find the x value. The x value is same as x maximum. Hence just replace x with x maximum. This is what I was saying all this time. And now I need to find the value of u. I need to find the value of y, that is the intersection, because directly I cannot say what is the value of y. I cannot say it as y minimum or the y maximum. I need to find what is the intersection of the y is going to be. Hence I am going to find the value of y now by using this form, where y equals 135 is the y3 value plus value of u is 0.67 multiplied with y4 is 52 minus y3 is 135. Hence I am going to solve this equation. When I solve this equation, I am going to get the y value 79.39. Hence this is also called as y dash, which I will be using for P4 dash. Fine. And so now I know what is the new value of y, and I know what is the new value of x, that is x maximum, because the intersection is at the edge x maximum or the right edge. Hence right now I am going to find a new point P-4, which will be made up of x maximum and which will be made up of y dash. Hence x4 should be replaced with x maximum and y4 should be replaced with y dash. Now the new point becomes 200, 79.39. The whole value was 220 and 52. Now it has been changed. It has been changed to these two new values, and there is an intersection point with P4 dash. Is it clear? So now with this I have find the intersection point. So now whatever the line I have been find intersection, I have been clipped out and I will updated this P dash. I updated P4 as P4 dash, and even I have been changed this value to X4 dash and Y4 dash. Now we'll go for step 3. We will not stop at this step. We'll go for step 3 and even we'll go at the step 4 also. And the step 4, the same process what I have done with the previous example, and just replace and check out the value of B, and it's going to be out of range. I need not worry about the X value. And step 4, similarly find the value of U. Again this is out of this range. There is no any intersection. Hence when I talk about this 4 values of the 4 edges, so only at this edge there is going to be intersection. Hence I need to find a new point only at this intersection, and I am going to clip out the part and display only this part of the line. And this is how we are going to make use of line clipping algorithm using parametric form or using the point clipping method. So but in this parametric form algorithm, it has got some disadvantages, because we are going to do all the 4 steps even though the line is going to be completely accepted or completely rejected, still we are performing all the 4 steps. Fine. And this is what one major drawback of having a parametric form line clipping or point clipping method for the line clipping algorithm. So we have a better algorithm than this, so which is going to help me in doing all this kind of line clipping operation. This is what I told you. The efficiency of a line clipping algorithm will depend upon minimizing the number of intersection operations. Hence, so we have got an efficient algorithm which is called as Cohen-Sutherland line clipping algorithm, which is better than the parametric form. Hence, we will discuss about this Cohen-Sutherland line clipping algorithm in my next video. So just check out for the algorithm in my next video. And thank you for this session.